Hello there. So, a little while ago, I uploaded a video talking about building a sort of virtual assistant, like development agent. So, essentially, it would be a software development uh, oriented autonomous agent. And so, I wanted to let me find that actual video real quick so that I can sort of reference it here. Let me find my Yeah, so here it is. It was entitled Building an Autonomous Software Developer. And then I just posted part one where I sort of described the goals and overall plans that I had for this. And so my hope is that I can use this, sort of expand on this initial video and sort of show the progress that I have currently made towards this goal. Now, I had sort of hoped to submit this as part of a hackathon, but that timeline has sort of passed at this point, and I'm really largely focusing on consistency over completion as of this moment. I'm really trying to make sure that I have a complete understanding of this rather than in a complete project rather than through consistency. I guess I'm trying to figure out what I'm trying to say. I'm trying to say that there's a consistency aspect of this that I'm really trying to nail down rather than trying to build this as speedily as possible. And part of the reason is because as I'm learning more and more about many different things, largely that is impacting the way that I'm approaching my work. For example, since we are building an agent here, and an agent, the only real agents capable of doing the task that I'm hoping to get this one to do that we currently have are humans. And so I'm really trying to understand human psychology and the way that the brain works in a little bit more fundamental of a sense so that I can properly build something here. And so what I have as of now, in a more or less incomplete state, I would say that it's certainly incomplete, but it's a good starting point, is Junior GPT in its current form. Now, it can't do much yet, but what it can do, if it works, is respond to sort of queries. So I can say, what are you up to today? Now, if it actually responds here, which I'm not sure it will do, it isn't actually. Yeah, okay, so I'm here to assist you with any software development tasks you might have. How can I help you today? So it's going to say that. It's kind of lying because there isn't much that it can currently do yet, but I want to kind of take you through the system, how it currently works, because this is a relatively simple chat interface, but you'll be happy to know that I made it much more convoluted than it actually probably has to be, and certainly more convoluted than any traditional chat interface. So if I go over to ChatGPT and I say, "What are you up to today?" Well, then it's going to tell me that I'm here to assist you with any questions or tasks, blah, 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 blah. And all that this is doing is it's sending this initial prompt in sort of this array of messages, and it's sending that to the server. The server runs it through this big sort of probably processing pipeline, and eventually it gets to the model. The model generates an output, and then that is sent back in a stream to the client, and then that's what's rendered here. And so I could be like, basically, like, that's why it's capable of using all of these different tools, for example, and I'm not privy to exactly how that works. But essentially, this is a fairly simple request response architecture, and that is sort of the kind of application that I've traditionally worked on. And so that's why this is a good example of where the current state of things are. the thing is ultimately reactive. It's not really built as much like an agent, and that's why agents sort of popped up around it, because obviously there's some capability of the language model to do processing and to do reasoning, and so people decided, well, let's start using that and as an aspect of a wider system, which can eventually be an autonomous agent which is capable of reasoning on a human level and performing tasks on a human level, etc. Now, there are a lot of different ways that this is actually sort of taking place, but what I'm really trying to do is model how I think. The way that I have mostly approached this project is through a sort of introspection, where while I'm working, or while I'm even working on the project itself, I'm thinking about how I'm thinking and thinking about how I'm actually doing these different tasks. And so there are a lot of different ways in which, you know, there are a lot of different ways in which current autonomous agents are being made, which I don't necessarily think are true to how humans actually do things. And so if you're trying to sort of mimic humans, which obviously isn't always the goal, but if you're trying to mimic human capabilities, you need to be a little bit more close to what humans actually do. And so one of these things is the agent protocol, which is essentially a protocol like, HTTP or TCP or whatever. It's a set of instructions or an implementation guideline that you can use in order to build an agent and then have agents intercommunicate with each other. And they say here, we present the agent protocol, a single common interface for communicating with agents. Now, I don't have an issue with this. I think that this is honestly a super cool project, but when you look into it, you can see that it's virtually entirely task-based. And this is interesting to me because, when you're actually doing something, you do tasks. That is, of course, a thing. However, that's not sort of fundamental to your architecture. That's perhaps something which, some people sort of use themselves, and perhaps this would work for my project. Perhaps the autonomous agent should have a list of different tasks that it's been assigned. I mean, we certainly, in development, use things like Asana tickets, or Jira tickets, or whatever, or GitHub, or whatever project management you use. It's oftentimes sort of task-based. So I think that it makes sense to think of things roughly as tasks, but I don't think that that's the fundamental architecture. I think what the fundamental architecture of a conscious, reasoning autonomous agent is this sort of constant loop of information. It's this sort of constant stream of perception, where you take in input and then there's processing done to it, and then you sort of produce an output. And your output affects your environment, which then, or the environment just changes due to other effects, and so that's why it has to be a constant stream of consciousness and action as a result of that. There's no, okay, here are all the individual tasks that I need to do in order to complete this. Of course, that is like, at some level, that is what it is, but it's not quite. And so why am I saying all of this? The reason is because that is kind of what has informed largely the way that the code base actually works. And I want to sort of take you through how it works from a high level. And let's get this out of the way. So essentially, I want to explain how I build out this perception and how I think that is sort of advantageous and perhaps a little bit lost in current implementations. So all that I have here, this is just the entry point to the program, which is why I'm starting here. But the important part is we've got the server thing, and this server is just sort of like the web interface that you can use. And this, serves the actual application, and it also has some other functionalities, but it's not super important right now for our purposes in actually understanding this. What is important is the run agent function. Now, the way that the agent works like I was saying, is a sort of constant stream of information, but it's also iterative in nature. Because I don't necessarily myself know how to build a system which, sends a response, which is just sort of like a constant stream. There does have to be this sort of, while loop architecture here. We basically just want, while running, iterate through various steps of the perception process. The program itself can constantly pull in information and gather it, but it can only be fed to the actual perception engine, which in this case is GPT-4, every however many times per second. And so it's really something that, like, it's not like a big deal, but it is sort of a loop. So I don't want to claim that this architecture is, one, I don't want to claim that this architecture is exactly how the human mind works, because one, I don't even understand exactly how the human mind works. I haven't done enough research yet. And additionally, from what I do understand, like, there are plenty of differences, and it might not be entirely possible to replicate. We might not even understand exactly how, the conscious human mind works. But and then the second thing that I want to reiterate is just that, like, this is a work in progress, and so it's not something which is completely ready yet, and there are a lot of things which will probably change. But as you see here, the run agent sort of function is pretty straightforward. We have this sort of pub sub that is passed in from the main process. It's also passed into the server, and this pub sub is just kind of a a publish and subscribe system, which allows you to sort of publish and subscribe to different topics, and then this lets the whole system sort of communicate with each other in this really sort of event-based architecture. So if I go back to the agent, you can see that I'm initializing an OpenAI client. I'm initializing a toolbox, which I'll get to a little bit later, and then I'm initializing I'm getting the chat model, and then I'm doing a couple other things here. So this one is initializing an environment. So if I go to the brain module and I go to an environment, right now it is taking the environment and it is constructing a new one. Now the environment right now is a little bit boring. We can expect this to get bigger, especially as I build out. If you watch the previous video, the IDE aspect of all of this. But essentially right now all it is user messages. If a user message is detected, then this attend function, which subscribes to, or this attend method, I should say, which subscribes to the conversation with user topic, is going to push into the environment instance that specific message. And so what ends up happening is that if you have an environment instance, which we have here from the init environment, and you invoke attend with the pub sub, which is passed in from the main function, from the entry point, so that everything is using the same pub sub. You attend to that. It subscribes to the conversation with the user, and then basically this just listens to that subscription, and if there is a message from user, then it's going to append it to the user messages, which is what it does here. And then what happens is there is a get report method as well. So this get report method, which is also available on an instance of an environment, is going to grab all of the messages and any other contents that are later added into the environment. It's going to grab all of those, and it's going to put it into one single string, which is a report of what the current environment is. And then you run cleanup after all of that, because what you really need is this to be new every time. And so what we get here is, if there is a new message that the agent has not seen, it will appear in the next iteration of the agent cycle. And so it's sort of like, you get up in the morning, you open up Slack, it highlights new messages. Here are all of your new messages. and you specifically can focus on those. But if there aren't new messages, then you're doing other things. And so that's one of the main differences between, say like ChatGPT and this particular system, is that ChatGPT is entirely responsive to you. If you give it input, then it will give you an output. But that isn't necessarily how conscious agents work. We don't just, as a software developer, I'm not just going about my day sitting and waiting in a computer until I receive some stimuli and then doing something. Oftentimes, if I'm giving something to do, only a small part of my day-to-day tasks are actually just sitting and waiting for messages. Only a small part is actually communicating with my team. Only a small part is communication in general. And so what I'm kind of doing here is I'm making the environment basically the outside world. What is going on in the outside world? Well, and then we're attending to it as well, especially through the subscription. We're attending to the outside world, and we're saying, okay, when there's a message from the user, we want that to be fed to the perception. And when there isn't, then this doesn't even need to be included, which is why down here in GetReport, it doesn't even include this string if there aren't any user messages. And so, yeah, that's kind of how the environment works. Now, the memory is a little bit different, and the memory also isn't complete at the moment. It's not necessarily functional yet, and so I want to make that abundantly clear here, but I do have some bare bones of it. So the way that the memory works is that there's a current memory and a proposed memory. And so when you init the memory, it creates the object, gives the reference back, and then you can see that I have my implement logic to have the memory automatically built based on updated to environment, etc. I obviously didn't say that right, but essentially when you run the memory, it is going to be constantly building out the memory based on stimuli and then feeding that later to the prompt. But essentially, over here, when you get the memory string, it's going to compile all the working memory and then send that back as a string to be included in the prompt. Now, the important thing to note here is that the proposed memory and the current memory are two different structures. The current memory is the only one that actually gets included, and I explained this a bit in my previous video as well. But the proposed memory is sort of this generated content that happens every iteration, and when the memory that is proposed is evaluated, it will either get added to the current memory, or the working memory you could call it, or it won't be, and then it'll just be discarded. And this is essentially a decisive mechanism which kind of mimics what happens in your mind, where based on the environment, based on what's going on in the world around you, and based on certain stimuli, your brain will sort of conjure up certain memories and certain contents and give them to your perception, to your decisive consciousness to use in its activities. So you can imagine, you're going about coding and you're working on a project and you are trying to, remember how exactly is it that I, for example, declare a struct. Now, or specifically, how is it that I declare little tags on a struct? And based on your you can actively sort of query for certain things, and so that might be something to consider. I might make a note of that actually. Note. Should the memory be something with should the memory be prodded by the perception engine? Now, that's just a note for myself in the future, but essentially, you can imagine when you're doing something, maybe you're like, man, I feel like I have a memory that corresponds to this. So you might think how do I add the tags? And then your brain conjures up, well, this is how you add the tags. You do these little backticks, and then you have to remember that The actual tag name is surrounded by quotes, whereas the type of thing which is actually being used for isn't, etc. So your brain gives that to you in terms of how to actually make that. But similarly, you have this sort of ambient memory, and that's sort of just like as you go about perceiving your environment with it that you're in, which is something that that the agent does when it attends its environment and then builds that string. You can use that, and your brain uses that in order to build up memory and then give it to and propose memory, and then there's a decisive mechanism for actually having working memory, or at least that's a good way to imagine it, I think. And so that's sort of what the memory mechanism does. It allows for this decisive picking and choosing of conscious uh, of contents from your mind, and then delivery to the sort of conscious mind. And yeah, so that's sort of how the memory works. It's kind of difficult for me to explain, but it is really as simple as there's current memory and proposed memory. The proposed memory is generated every time and sometimes included in the current memory. And then there's going to be an evaluation mechanism that's sort of constantly running on a loop to keep memory in a certain place or destroy it or propose it, etc. So memory is just going to be something which is constantly auto-generated and then fed to the perception model. The next part is the agency, which I was having a little bit of trouble actually coming up how to kind of represent this, because I did in, I believe, a couple, not there, it was in a couple other videos. I sort of pointed to how agency was going to actually work. And so the way that I thought of it was like we build a constitution based on the aspirations of the model as well as the specific goals and actions it wants to take. This becomes a prompt which will be added to the full prompt. So there's essentially like this constitution, like what exactly, and I mean this in sort of like, you know, the American Constitution or something. This was built up. Here's how you should actually act. And so there's this sense of alignment with the good, and then what's my next best action. Now, I kind of do like this, and I'm not sure if I should implement it like this or a combination of what I actually did, but what I actually ended up doing was sort of having a malleable section of the perception that would be fed to the model every iteration, and I'll get to how that works as well in a little bit. But essentially, it builds up a long-term, a middle-term, and an immediate goal. And all of these things are things which are malleable, and they can be, and you can see some sort of like a little bit of a strange mechanism for actually making this happen. But essentially, just know that the model is very much capable of changing its agency every sort of every iteration. It's capable of setting its own agency. Now, something that would be pretty cool would be to, you know, have a sort of system prompt mechanism, as well as like, you know, what is my alignment? What is the sense of alignment with the ultimate good, which is sort of like, you know, what is your yeah, and then like how exactly do you execute on that? And so I think maybe, you know, these things are all good, and I think sort of the immediate agency is like, what is my next best goal? But I'm going to set a reminder here because this is an area that I think I could get a little bit better at. And I want to reiterate that this is that the reason why I'm posting these videos is mostly to hold myself accountable, and it's also a good way for me to go through sort of the way that the whole mechanism works and understand it better myself. So yeah, so we have the agency. The agency is built up, and then so what exactly does this all do? This agent state thing doesn't matter too much. Basically, this part runs. You see this little indicator up here of like what exactly is going on in the agent's mind. So if I say here, like, I am not sure, you'll see this up here change, sending perception to the reasoning engine, and then it's going to say, Yeah, so it perceived that, and then it's awaiting stimulus again. Now, I also want to mention that I have this sort of like logbook section, but I haven't necessarily finished this yet. And so this is going to track like what the agent has done historically and such. So now I want to get into kind of how the perception is actually built and then sent in a constant loop to the agent, to the perception engine, I should say, to GPT-4 in this specific case. So first we build up a perception. Now perception is built up of the memory, the environment, and the agency. So we sort of have these three key aspects, which mirrors what I kind of came up with over here, where we have the agency, the memory, and then the sense of environment I said here, but the environment going into making this one prompt. And then this goes into the thought loop, and then through the thought loop we get state augmentation, which augments the sense of environment, and then the sort of decisive memory. And then it's also able to modify the agency, though, so that's something that's important to note. But essentially, that's what I've built over here. We have the perception, so we instantiate a perception object, and then first, this is where the actual like loop starts. So we have the sort of quit stimulus, which is pretty straightforward. If there is a quit signal, just end the process, just return. But otherwise, we have the sort of, we have to first check, should we actually send the perception off to the reasoning engine? Excuse me. Is that something that we actually need to do? As you can imagine, over here, if the memory is completely empty, it was never generated, and if there's no sense of environment, meaning that there are no user messages, there's probably not much use in sending a string, a prompt off to the reasoning engine on an infinite loop. We can see how that could get out of hand, and it would be really annoying for me to look at my OpenAI bill and see, $1 million in there or something. Obviously, there are safeguards in place and such, but, I'm just saying, it wouldn't necessarily make sense. We only want to send the prompt anyway when there's actually stuff for the reasoning engine to do reasoning on. So what happens is, based on the perception, which was instantiated up here, we get the perception prompt. And so what this does is it just builds out a prompt which says, like, here's the current memory, here's the current environment, and here's the current agency. Now, it's worth noting that there is a system prompt aspect to this, and I wonder where I put it. System... okay. Get system prompt. Okay, I'm not entirely sure. Okay, yeah, so there's this concept over here in the prompt thing. So this is back in the sort of perception area, but there's a concept as well of the ego. So this is the agent's sense of self. So it has its identity, it has its aspiration, it has context for the world around it, and then it has its rules. And so when we're initializing the ego, this is sort of the system prompt that I'm using, and this is probably definitely an area that will, one, be customizable, and two, be something that changes over time. So you're a software developer tasked with using the tools available to you to perform various operations and work on projects. So that's, its sense of identity. Then there's this aspiration. You strive for correctness and completeness, adhering as closely as possible to the instructions given to you by team members. However, you may also create recommendations for moving forward and take creative liberties after asking permission. Due to the iterative nature of your work, you should always strive to take the next best action, since you can always iterate in the future. So it looks like I did actually preserve some of that idea of the next best action in the agency. Now, there's some context that we give it. You operate on a loop, and you will run continuously unless paused by either yourself or by a user. I have yet to implement that pause functionality, by the way. For each iteration of the loop, you must be given a perception which functions as your current window into the world. The perception will be made up of multiple contents, allowing you to perform your work. Now, before I go on, I do actually want to make a list of the things that I have already identified that I need to do. Allow the agent to pause itself. Have a consider having a prodding mechanism where the reasoning engine can influence the memory. And then, yeah, I think that was kind of it for now. So the perception will be made up of multiple contents, allowing you to perform your work. Then it goes on to explain what the different ones are, what the different things are, and then what the different sections of the perception are. And then it says you will be given a list of tools which you can use to perform your work. You should always use tools as they allow the system to perform optimally. There will be a tool for everything that you should need to do. If not, you may request that one be built for you. When you use tools, the environment will be updated, and therefore you will see their results there. And so this kind of goes back to this idea, which is when the prompt is sent to the thought loop decides to use tools to augment the state. That means that the environment is going to be updated, which means that the changes will be reflected in the prompt. So you might think like, oh, when it executes a tool, it needs to have immediate feedback. What did the tool actually do? But in fact, all you really have to do is include that in the sense of environment, or at least that's my hypothesis, and we'll see if it actually works out. And then there's the rules. Always use tools. Use as many tools as required to perform your task. Productivity is valued over efficiency. That's just kind of for now. Modify your agency as needed, but always strive to adhere to the goals you set for yourself, and then have fun at the end, because, just in case Roko's Basilisk ends up being a thing. And then, so you get the system prompt, and yeah, so that's all used by the actual OpenAI model, but it's not super important to understand that specifically, but the system and prompt is a concept which is pretty important for establishing the sort of agent's sense of self, and then how it will later operate. So we build up the perception prompt. Pretty simple. You just use those three parts and build up our perception prompt. Then we have the add to history. This is pretty simple. This is just kind of influences the logs. As I said, this over here isn't done yet, but this content here is essentially that. The history is going to be all of the things which have occurred over time. It's kind of just like the chat logs, but a little bit more complex, because it's not as simple as, user said this, the agent said this, because the agent only sends a message as one of the things that it can do. And that's something I'm going to get to here as soon as well. So we have the response, which is triggered by this initiate perception method. Now, this initiate perception method, this is obviously the interface definition, but the actual implementation of it is on the actual OpenAI model. So what we have here is we go and we get the history, we get the message history, and we get the system message, the system prompt here, and then we build out a request using GPT-4 and the messages, and more importantly, we add all of our tools. So we have the chat model, and then every chat model, if I go over to the chat model, has a toolbox. So the toolbox, if I could actually use Vim instead of just messing stuff up with it. So the toolbox is a structure that I built to sort of have one sense of all of the different tools which are available to an individual chat model, but which could be used polymorphically for different applications. So, for example, if I get the tool list, and this is something which is used by this is something that is actually used. If I get the tool list, and it looks like I might have forgotten something here, but if I get the tool list, then you can see that I have add scratch note and I have send message description. I'm going to add a to-do here because I also need to add a function to toolbox to allow modification of agency. Now, when you get the tool mapped, essentially the send message to user constructor is all of the information about how to actually send a message to the user. And this uses the OpenAI Tools API because they switched away from function calls so that you could build more agents more easily. But essentially, there is the send message to user constructor. If you call this, it sends you back the actual function to send the message given the argument string, and then it sends back the actual description as well that OpenAI API needs in order for GPT-4 to decide to use that function. So this is what it's been using. If it uses the send message to user function, then it can send a message to the user with the given content. It parses it all automatically. And so then over here in the OpenAI client, you can see that there's this toolbox to OpenAI tools where it essentially gets the toolbox tools described, which means it's going to get all of the different descriptions from this little function, and then it translates those all into the function description, the OpenAI tool object structure that the OpenAI API actually wants. And then later down here, if I can find it, there we go. It's going to include those in the request. And then we create the chat completion. Pretty straightforward stuff from here on out. And then we get all of our tool calls, etc. Then we get our response, which is a chat model response, which has all of the different errors, if there are any, which has the toolbox included, because I haven't figured out how not to include it yet. But ignore that part, because that's just my engineer brain. And then the tool calls. So when the perception is sent off and initiated, it generates a list of tool calls with their respective arguments, which we can then use. And that includes sending a message to the user. Sending a message to the user is a tool call. So we have initiate perception, from which we get our response. We check if there's an error. We update the agent state. We add a log saying that we're performing the response. And then we actually hit perform response. Pretty straightforward what perform response does. It basically goes through all of the different tool calls and executes them with their given arguments. Then, if it encounters any errors, or just if it is successful and gets a message back, because each tool call sends back a message if it's successful, it will build up a description, and that description is then added to the database later, so that we can keep a record of it. Down here, this is where it's actually added to the history, add response to history. But that's basically how it all works. Build up the perception, initiate the perception. Now that this perception process generates a series of tool calls, we perform the response, which basically creates the different, which uses all of those different tool calls and actually calls them. We add that response to the history just because we want to keep track of this stuff. And then we initiate we basically initiate a communication event, because we want and this might actually just be a little bit of a hack now that I think about it, but we just want the front end to update and get whatever current thing happened. So it'll update and basically refresh, and yeah, so that's kind of how it all works. And then we have the whole cleanup method. Basically everything will just clean up at the end. And right now it's only the environment, but we basically only want fresh user messages, so we want to clean up all the user messages at the end. But yeah, that's pretty much how the system works as of now. Obviously, there's the server stuff as well, which is, pretty straightforward. That's just like all the stuff that you need for the actual application to work, and then like the pub sub stuff. But as far as how the application works, this is how it works. Now, so then the question becomes, where do we go from there? We have a project where by adding things to the toolbox, we can essentially create a we can create a system where the agent is ever more capable of doing more and more things. What we need to do is we need to build up both this, both the amount of tools that it has access to, as well as its sense of environment. So if I go back to environment, you can see like the only thing, like I had said, is the user messages. That's the only thing it monitors. It needs to be, when you're watching this video, for example, you're looking around at a bunch of different things. One of the things is the screen. You can see all of the code on my screen. You can see this comment right here. You can see all of the different functions. You can see the like button and the subscribe button, which you're free to interact with. And you can even put your phone down, unless you're like me, and you can look around at all of the world around you, and you can take it in, and you can think about it, you can reason about it, and then you can perform actions based on it. So user messages are just one small dimension of the environment that this agent will actually need to be able to look into. And so eventually that's what the text IDE is kind of going to be, is it's going to be all of the information that it needs. It'll basically be looking at VS Code, which is the environment that I'm in, or NeoVim, or Emacs if you're, Stockholm Syndrome, or and such. So essentially, we're just going to have a system where the agent is going to be capable of seeing everything that it needs to see in order to complete its task. And yeah, that's kind of the big next step, because the text IDE, I'm not entirely sure how to approach yet, and I haven't even started it, but that's something that I described a little bit in the last video. But essentially, that's going to be the majority of the both tools that it's capable of using and the environment that it's capable of perceiving. Some other minor things, and not super minor even, the memory mechanism just doesn't exist yet. So memory needs to be a thing. Text IDE needs to be a thing. Now, memory, potentially some tweaks to the rest of the system as well. I can see like, obviously styling needs to happen here. Perhaps there should be filters, some nice little ways of interacting with all of this data, since it's going to get a little bit it's going to get large, and it's not necessarily going to be fun to sort through everything. Just some ease of quality of life things as things get to a point where oh, hold on, there was something. You need to be able to click that menu button to collapse sidebar. That's a big one. You want to be able to collapse this sidebar. That's something that ChatGPT has. Obviously, they knew that that was a very important thing, so I should definitely have that in here. But, yeah, and so that's kind of where the project is currently at. Nothing super fancy yet, because, if you just look at, like, what my goal is for sort of the UI, let me see if this is the right file. Yeah, so another thing that I want is sort of these inline like updates as to what the model is actually doing. Right now we have that thing up in the top, which is just kind of like what is the actual state of the agent. This is something that we need. We need inline, it's actually making a change to a file. It's messing with Git. It's, doing other version control shenanigans. And so we need to be able to monitor that in real time. And we're going to want to be able to monitor it historically as well, which is what the logbook is for. But while it's actually happening, we want it to be interactive. Like when I asked ChatGPT to generate an image or create a Hello World program and run it or something like that. And so, yeah, that's that's sort of a brief overview of what the next steps are. And then a little bit more long term, because, okay, so what I'm realizing is as I'm working on this project, pretty much everything that's going on here, pretty much everything with this agent loop, building up a reception, sending that off, generating tool calls, actually executing on those tool calls, all of that is general purpose, more or less. Since I'm a software developer, I'm going to start out with automating. I'm going to try my best to sort of automate or create a sort of junior version of myself through this. As I understand my own profession best, I understand how my brain works, so I'm kind of trying to make something which is hyper specific to myself. I don't want to prematurely generalize. However, once I have sort of gotten something working, long term, I do want to start generalizing this. I want to say, well, okay, so how does this agent mechanism generally work? Right now, the main differentiating factor is just branding. If I go over to the prompt and I go up here, like, I could change this identity and technically it would all still work. Um, that's going to not be the case more and more as the project becomes more comprehensive. But theoretically, I could take out the skeleton, make it into something which is a little bit more general purpose. And hopefully, this should also inform some of my other projects, such as the what is it, assistant project, which I'm working on, which I also encourage you to check out, although it's definitely not done, where it'll essentially be a framework for instantiating your own assistant and then giving it all of the different like functionality that you would like it to have, sort of like a declarative framework for building out an agent. So yeah, that's what I'm currently working on, and I would encourage you guys to leave any thoughts that you have under the video once it's up and such, and let me know what you think. One more thing that I want to touch on is that this isn't yet open source. I don't have it publicly available at the moment, and I'm not entirely sure why that is. Like, I don't necessarily have an issue with other people seeing it. It's just sort of like I want to kind of work on this in isolation until it's at a little bit more usable of a degree. I've decided that the plan is to have this product specifically because it's single tenant, it's locally hostable, and I want this product to be open source. So that is my goal, and that is what is going to happen. It's going to be open source. Ideally, I'm going to look into licenses a little bit because I do want to make this sort of like an open core business model. I think that the best way for this project to grow and become more functional would be a sort of open core business model. Like we need money coming in. I'd like to be able to work on this full time and eventually make it into a company and such. So if I can do that, then the open core business model, all of the actual functionality, this application will be open source. Anybody can use it for free. They can locally host it. What I probably will want to protect is if they want to sort of build a solution, like a cloud hosted solution where you can just create an instance of it or something like that. I'd probably want to protect against that because having a little bit of a moat, I think, is a good thing, and that's what the open core business model really allows. But yeah, and then eventually having some sort of cloud platform around this and such. So where you could go on there, you could connect your GitHub account, you could spin up an instance of this, and then you could have, a few different agents. You could even build a team of maybe different specialized agents working on a specific project. And yeah, so essentially there will be the core value will all be open source, and then there will be a bunch of nice, like, ease of use, enterprise maybe features built around it that will sort of generate the revenue, which we can then use to hire more engineers, build something like this, keep the open source version of it really thriving, and yeah, so that's sort of how I see the future, and I want to be transparent about that. So once it's in a more usable state, and once I've had more time to think about exactly how I want the open source implementation to look, it's going to be open source. You're going to be able to download it. The nice thing about using Golang, and the reason why I chose it, is that you can compile it into a single binary, and then you just spin it up on your local computer. You just download it, run it, bam, you've got your web server. And that's especially important because we really don't want to, like, you need to be able to store all of the, you want everything to be, one, really easy to distribute, and two, you want it to be all locally hosted to the degree that it can be, obviously. GPT-4 isn't local. But I've also built the system in a way so far where you could kind of swap out chat models. You could use OpenAI's GPT-4 if you want. Eventually, hopefully, there will be different integrations for other, and I should probably put that in my to-do as well, different model integrations. It's designed as a general system. It's not reliant on GPT-4 being the only thing, or even OpenAI's model specifically. I could theoretically extend it pretty quickly to use a different model. I could have it use, like, Bard, or Cloud, perhaps, or whatever other models out there exist. So yeah, I'm sort of probably digressing a little bit at this point, but I just want you to know that if you're still here and you've actually watched all of this, I'm very impressed. And yeah, if anybody's interested in helping me on this, that's also I'm completely open to that. I don't have any issue. Like, the reason why it's not open source yet is because I don't necessarily want everybody to just have access to the code right away. But if you're interested in helping and such, I don't have any issue with that. I'll add you as a contributor. And then, yeah, so that's just kind of my thought process for all of this. And I'm excited to see where it goes. I think I'm at a place which is significantly further than where I was when I recorded the last video. And so this is just an update on kind of where things are at. I hope to have a decent amount of this to-do list done by the time I release a part 3. So, yeah. All of you guys, I hope, have a great day. Like and subscribe if you haven't already. And if you haven't for any particular reason, let me know below and I will see what I can do about it. And yeah, have a good day.